Let us start with the situation. Given a problem statement to you, I've given a problem statement to you. You need to develop an algorithm, and after that you will write the program corresponding to that, right? So in that case, you will say it is computable because the computer can use the program and compute that, right? So here my point is on this word. Our emphasis will be on this point, on this word computable. So what does it mean for this word computable? What does it exactly means? So anyone would answer that given a problem statement, I will be developing an algorithm corresponding to that, and if that algorithm is represented in pseudocode, that pseudocode can be converted into any program in the respective programming language. So here are some of the examples here, like checking whether a number n is prime or not. So definitely we can develop an algorithm, write the program and execute, and based on the inputs we can receive the outputs. Same for the product of two numbers, or sorting a list of numbers, or finding the maximum number from a list. So these are computable. Now think about a situation that what could be a situation, or which class of problems could be there which is non-computable. Think about it. So here we'll focus on the word computation. So this word computation, I'll just bring it with some follow-up questions. First is, can we define computation without referring to a modern computer? Because whenever we think about this word computation, the computer comes into the picture, the typical desktops, right? So think about it. That can we provide a stringent definition of computation? Think about it. Next, can we define mathematically what a computer is? The answer is indeed yes, the Turing machines. Next, is computation, can we provide a concrete definition for computation, for the word computation, independent of present day engineering limitations, that is understanding of physics, chemistry, quantum computing, or whatsoever? And the most important question, or the most interesting question here, can any computer, be it digital computer or quantum computer or any xyz that we are not aware of, any computer solve any problem? Can a computer solve any problem given enough time and disk space? Now here, one word that is questionable here is enough. What is enough? Whether it is 10 power 9 years, whether it is 10 power 100 years, what is that enough time actually? So this is a very interesting question. And all of this, for all of this, we can establish an answer. For example, let's say if I utter a statement, God exists. So God exists. Now there is a class of people who will say that answer is no. Some class of people will say yes, and some are like, we do not know. We do not know the answer. If I say yes, I cannot prove it. If I say no, I cannot prove it. Hence, I choose to answer this way, that I am not aware that whether God exists or not. Right. So now these questions, we will explore, we'll try to explore the answers of these questions in this course of theory of computation. That means we study all the mathematical implications or the critical points of computation in this course of theory of computation, and this is the umbrella term for multiple other topics that are present within this course itself. Before proceeding towards the upcoming discussion, here I would like to provide a strong suggestion for everyone, anyone who is from the field of engineering, mathematics, science, they must watch this movie. Now coming to the students or the learners who are related to this course of theory of computation, strong suggestion, before you complete this course, or if you are new to this course, watch this movie once. Maybe you will not get 100% understanding of that, but once you have completed this course of theory of computation, come back to this and watch this movie again. So that's a strong suggestion from my side. You will enjoy the beauty of this movie once you have the clarity of this course of theory of computation. Now, so one of the primary objective of theory of computation is to understand the mathematics of computation. What are computable, what are non-computable, and what are some of the problems where we cannot comment whether it is computable or non-computable, right? Now, in this course, mostly we study these things. We make mathematical models, that is the computational devices, and we execute algorithms on those model. If you have studied algorithms, you might have heard about something called RAM model, random access machine model. So various computational models are designed mathematically and algorithms are executed on these machines, right? Models for the problems machines can be used to solve, and then theorems about what kind of machines can solve what kind of problems and at what cost. So these are the major concerns. Now, also the questions relating to what can and what cannot be done by machines are covered by considering various models of computation, including Turing machines. That if there is a Turing machine, then what it can do and what it cannot do, or universal machines or recursive functions. For example, if you take your laptops, desktops, MacBooks, or whatever, these are also implementations, or you can say these machines are inspired from Turing machines. Rather, I personally believe, this is my personal opinion, I believe that anything and everything is Turing machine. Again, this is a debatable point, right? Now, what are the topics that one has to cover as at an undergraduate level? Regular expressions and finite automata, context-free grammars and pushdown automata, regular and context-free languages, pumping lemma, and most important, Turing machines and undecidability. Right. Now, why study about this course? My one-line answer is to understand compilers. Now, generally, undergrad students, they want to get into a product-based company, right? So, one of the company which sets the benchmark for all the software engineering aspiring software engineers. So, this is the SWE interview prep guide from Google. So, I'll just search the word compiler. So, you can observe here, if you are if you are into the interviews of this kind of companies, right? Google and Google like companies, then they're definitely expected. As a computer science engineer, it is expected from you that you should have good hold on compilers, right? So that's why, again, when it comes to the heading of this computing foundations, so you can clearly observe that you must possess a solid understanding of fundamental computing concepts, and compiler is one of that, right? So in order to understand compilers, one has to study theory of computation, and that is one of the primary objective, right? So generally undergrad students, they question me that why should anyone study compilers. So my answer is very simple. If companies like Google is mentioning in their page itself that one should have a undergrad student who is going through the interview procedure, definitely the problems on compilers will be expected from you, right? Yes. Now, for the sake of studies, or for the sake of knowledge or motivation, you will learn about how to formally reason about computation. Then you will learn about technology independent foundations of computer science, and then you will also learn theorems about what kind of machines can solve what kind of problems and at what cost, right? And of course, this is also a very important point, that to understand compilers, theory of computation is extremely important. Now, objectives that one will achieve. One of the objective here, proving that it is impossible to check if a C program will halt or not, or a Java program, or a Python or Kotlin, any program, right? So about this you will get to know. Formal proof. You can convince a friend using paper napkin argument. Just search about it, right? And the most important line, okay, which generates implications on or questions on artificial intelligence as well, that no computer ever, yes, I have mentioned this star, it is not a LLM generated word, okay? So no computer ever will solve this problem, not even a quantum computer, right? So these are the objectives that you will achieve, and you will be able to enjoy the beauty of computer science through this course. So with that, I'll make a closure, and I hope that is very, very clear that why one should study about theory of computation. Once you have completed this course, watch this movie before starting the course and watch it after, and you will have a altogether a different view about this movie, right? And with that, I'll just take your leave.